going to start right away doing this Python speed training, Python A to Z fundamentals in 60-ish minutes. And I want to welcome everyone who's on here now, and maybe there's still gonna some people are still going to join. But we have a very tight schedule with just 60 minutes to go. So I want to start right away and hop into this by introducing myself. So my name is Martin, and I'm part of Coding Nomads, and I'm a teacher there, and I've been a teacher in the programming field for about 3 years now. Been working for Udacity before, and I'm also always a student, and I learned programming online by myself, getting into programming later in life. And I think that's like a valuable asset also for knowing how to teach programming for someone who's joining the field, maybe like coming from a different background. My background university-wise was biology, so I wasn't involved in programming there, but started later on out of interest. And out of this and out of my experience with teaching programming for a couple of years now, I created the Python curriculum for Coding Nomads. So that's what's happening on our online platform at the moment, and also what's being taught in this upcoming bootcamp that's happening in Bali in spring of 2019. And I tried to put into this curriculum everything that you need to go from beginner who doesn't know anything about programming and who's just interested in getting into this field, going all the way to having a good proficiency in Python. So why learn Python in the first place? Python is a great language because it's the #1 fastest growing language, programming language, and it has like just a ton of different use cases. It's being used everywhere from web development for scripting, task automation, and it's also very interesting, very hot at the moment for data science and data analysis and the fields that go forward from there, so machine learning and artificial intelligence. It's just a very well-rounded language that can be used in many cases. And one thing that's great about Python is that it's very easy to get started. Contrary to a couple of other programming languages that are easy to get started with, Python also scales really well. So you can get started with Python, and you can just keep doing Python all the way into building complex applications or into working with data science or using machine learning libraries and doing stuff like that. So it's just it's a great beginner language, and I really like working with it because it has a very clean interface. It's fun to read. It almost reads like English, and you're going to see this when we go forward in building a bit of code today. So what happens with graduates of our programming bootcamps? There's been some great success stories of people getting junior developer jobs, getting funded for their startups, and some of them also just take on more technical roles in their current careers. So they want to stick with their job, but move into the tech field. And there's a couple of companies that students of our bootcamp started to work in. That's really all I want to say about this for now. And I just want to jump right in to telling you a bit what we're going to talk about today. So I want to not assume that anyone knows programming here at all. So I'm just going to get started with the very basics of what do you need to get started, like what are the programs you need to install so that you can start writing code. And then I'm going to take a bit of a different approach by first showing you what makes Python so powerful, because one of the reasons why it's such a widely used language is that there's tons and tons of packages. We're going to talk about what that is in a bit, but essentially it's just code that other people wrote and that you can use ready-made and just very easily. We're going to talk a bit about writing files and reading from files. And then we're going to go into the Python basics and talk about what makes up this language, what are the basic data types, what are for loops. You might have heard terms like that before when you've read things about programming online. And then we're going to go a bit into object-oriented Python. Object-oriented programming is like one programming paradigm that is widely used. And Python has this, you can use Python in other ways, but you can also use Python as an object-oriented language, and that's what we're going to look into. And I've got a little Trello board here where we have the topics set up, and I'm just going to be moving them over there once we progress through the webinar now. All right, so one thing I also wanted to say is that preparing for this webinar, I built out a little project where I aim to like include everything that you need to know for knowing Python, and it just started to get pretty big, and I realized that I'm not going to be able to build it out within 60 minutes. So this is a slightly slimmed down version of that. That should give you a taste of what this project is going to be, and that's also going to be available. Kim is going to send it out So if you're interested, just look for that email, and then if you have a bit more time, you can go through the project as well. We're going to use some aspects of it in this webinar now today. Okay, so to start out at the very beginning is like the question, what is programming in the first place? And it feels like sometimes it feels really daunting, like writing these programs that execute something. What does that even mean? And so I just wanted to show you that essentially what programming is, and that also comes for Python, is like you're writing a text file. So here I'm just opening up the normal text editing program on Mac. What I'm going to do in here is I'm just going to write a very simple line that says print, I say, hey, everybody. And so this is just a normal text editing program, like anything like that you would open up like a Word document, or on Mac, this is the text edit. And I just save this as a Python program. So what I'm going to say is this is hello.py. And this extension here, the py extension, says that it's a Python program. And I'm just going to go ahead and save it on my desktop here. And what I can do now is when I use my terminal and go to desktop, that's what I'm doing here is essentially I'm just opening up the desktop in the same way that I would look at it like this. I can check out what's on here. You can see the same files and folders that are hanging out here. And also there's this new file that we just created from the text edit program. And what I can do now is I can say Python 3. That's calling the Python program. And then I'm typing the name of the file that I just wrote and then run it. And it prints out this is what I just typed in over here into the print command. And that's essentially what programming is. Like you write a text file that contains instructions that the computer can understand and read, and then you run it with a certain interpreter. In our case, that's Python. And the syntax that you're writing in the text file has to match the interpreter that you're doing. So that's the programming language. And it has certain rules, and we're going to take a look at this. But I just wanted to show you first that the basic thing, what we're doing, and just to demystify this whole programming thing a little bit, all we do is writing instructions in text and then running those instructions, like telling the computer to run these instructions. You can do this as simply by opening your text editor, writing this here, but there's also programs that make programming generally easier. One of those is PyCharm that I have here. If you look at this, what we can see here, we essentially have here on the side, we have like a folder structure. This big part here is our text file. So that's the equivalent of this file here. I can arrange it in the same way. There you go. So we have here, that's essentially what we have there. You have your text field here. That's where you write your text file, your Python code. And down here, you have the command line where you can execute things around things. So we can do the exact same thing that I just did over there in PyCharm. So I'm gonna go ahead and do that. Print hey again. And then I can go down here and run it. Be in the terminal. I'll take a look. Okay, so it's sitting in here, webinar.py, that's the file. And I can say Python 3 webinar. And the exact same thing happens as before. So that's just to show you that also this program, there's nothing magical about it. It's just it's called an IDE, an integrated development environment. And what that means is just that these things that you have to puzzle together from somewhere else. Otherwise, they're just here in one program. So I have a nicer overview. Now, I want to try to make you fall in love with Python in this 60 minutes. So I'm going to start off with something that's maybe not the most basic way to start off, but something that I think is actually very important to know about Python. And one thing that makes it really powerful, which is that there's so many different packages out there that you can that are already made and that you can use. And by combining all this information, combining all these packages, you can like do very, very advanced things with few lines of code and without knowing a lot of programming already. This has its good sides and its bad sides, but I want to show you now just how easy that can be. So there's the Python package index online. That's just a repository that holds a lot of these packages. And you can go and install something from there just by typing pip install. This means pip installs packages. That's the abbreviation for that. Pip install, and then you type the name of the package. I picked one out that's a very, very famous one and widely used. code request, and it allows you to interact with web resources. So what we're going to do now, I'm going to show you this here. Starting a line like this makes a Python comment. So in the same way that we were executing this print line before, that we had sitting here, print something. This is a line that Python is going to execute. And if I write something with a prefix of a hashtag, then it's going to just ignore this line and not run it. So what we're going to do at first is we're going to fetch a web resource. And we will do this using the requests library, which makes doing that, like getting things from the web very, very easy. I'll show you how. And first we have to install it. But I wanted to show you that in doing an install is very easy. Just type pip install and the name of the package that you want to install. You press enter, and then pip is going to fetch it and install it on your system. And now we're able to use the requests library. Yeah. What I need to do to use it inside of my script is I need to import it. So I say import request. There it is. And after doing that, I will be able to use it inside of my script. So I'm going to say, we can do a check. I can run this, Control R. We're not getting an error. That's a good thing because it means that Python can find the request library because we just installed it before. So what I'm going to do next is I'm going to say, okay, my response, my HTML response is going to be request.get, and just look at that, how easy it is to read. Like I'm saying with the request library get, and now it was suggesting me something. Let's look at this again. Good. It's telling me, okay, I'm going to need a URL there, and then we don't have to think about these things at the moment, but PyCharm is giving me a suggestion of what I need to run this thing successfully. That's one of the advantages of using like an IDE. So what I have up here is a very simple, this is just like something that I uploaded on the web. It's just a little recipe. And I'm going to go to the raw version of that. That's just a text file that's sitting on the web. So you see, I'm getting this from the web. So I copy this URL, go back here, and in quotes, I paste this URL into my script. So just these 2 lines of code is gonna give me the response that is sitting somewhere on the web. I personally find this pretty exciting. So let's take a look at this. If I say print out what I got here and the text, so the text of what was in there, and run this script, it's gonna connect to the internet here. That's all happening inside of this line. Getting this, returning this, essentially what we did here, but from within Python, and then print it out down here. And you see it's the same text that is sitting somewhere up on the web, only that we just got it in here with essentially the import line and another line of code. And there's a lot of complex stuff going on in the background, right? So this is not just, you can just, well, without this library, you couldn't just do that to get the text so easily. But that's what makes Python so powerful, is that there's all this abstraction going on inside of, like, with code written in these libraries that just, yeah. All right, I'm gonna stop saying, but you really just need a few lines of code to get a lot of stuff done. And I wanted to show you this at first. Okay, and starting from here, I want to go forward. Just to mention another thing about the packages is that this is one example for it. So this is for fetching web resources, but there's similar packages for doing machine learning, for doing data analysis, like all sorts of stuff, building a web framework, all sorts of complex things are made much easier with the power of Python, so to say. Cool. So let's dig a bit more into what was actually going on here on the lower level, like on the generalized Python level. So I did this import statement here, which told me to grab a package. That's the one that I installed before. I could also import another, like a package is just a Python file that someone else wrote. If I write a Python file myself and I call it something, which we're going to do later on, I can also import it in the same way. And then what I was doing here is I'm assigning a variable to a value. And that's a very, very basic concept in programming, variables and values. And let's look at this a bit more. So on this side, on the left side of the equal statement, I'm giving the variable name. I could have called this anything. It's just like a common way for web resources to call something response, but this could have been XTZ, actually not that but in small letters, because Python wants, like, there's a couple of syntax rules for how should you write variable names. One of them is that it should be lowercase. You can include numbers, but it shouldn't start off with a number. There can be no spaces. If you want to make it visually a bit more interesting, you can put an underscore. That's the most important one. I'm gonna call this one response again. So that's my variable name. Then I have the assignment operator. That's just an equal sign in Python. And then I have the value. And in this case, there's like something happening in the background that in the end results to this value. This is going to be my value. And that's just what it gets from the web. And you can think of that just like an arrow, essentially. Like, this variable is pointing to a value. Let's look at that with something else. I'm going to comment that out for now. So just telling Python to not run this at the moment. So let's make a simple variable that I'm just going to call var1. And for example, this can be hello. And then I can print this out. And notice that I'm typing the variable name in here. Before we were printing out directly the string. We're going to talk about that in a bit. But what I'm doing here is now I'm printing out the reference. So I'm passing in the variable name, and the variable name points. You can think of this essentially like an arrow that is pointing to hello. That's how I can interpret this equal sign. So anytime I'm going to speak to Python about this var1, it's going to know that what I actually mean is hello. So I'm going to run that. It's going to print out hello. So I'm going to show you something here. The Python interpreter is a useful program for just checking out things like we're doing now, like lower level stuff where we want to get a quick response to what we're typing. Because here I can just assign something. It's going to be var2, hey, and then it's going to give me the output right away. I don't always have to type print, and I don't always have to run this script, because here, again, you remember, like, here we're building this text file, so we need to run it. There's just this shortcut Control R in here, but what we're doing is we always have to run this file. What I'm doing in here is, I don't have, let me see if I can make this a bit bigger. So it's easier to see. Okay, sweet. So let's look a bit more. So that's variable assignment. Let's look a bit more about what are we assigning here. So what I did here is I wrote hello, and I put it into this quote. And in Python, that's that's a string. So that's how you're talking about text, essentially. If you want to use any text, you can always put it into quotes, and you can say, assign it to something. Var great day. Okay, you get the point, I guess. And that's just how Python handles strings. But strings is just one data type that's supported in Python. And actually in Python, everything is an object, so you can build your own data types. And we're going to do that later on when we're talking about object-oriented Python. But let's look at some other basic data types for now. So another one that's very commonly used is an integer. That's why I'm citing it with an I, and that's just a number. So that's a number without a comma point. I always call it comma point because I'm from Europe, but I forgot decimal point. This is how you say it. Okay, so this would be an integer, and that's just a normal number. What I can do with these numbers in Python, I can just use them for normal calculation. I can say 3 plus 3, and Python is going to act as a calculator and give me the result. I can use my variables in the same way that I did before. Python knows that when I say I mean 3. So I can say I times 4, and I'm going to get 12. And I could assign 4 also to a different variable. I can say 4, that's 4, and I can say 3 equals 3, for example. That's just to make it easier to read. I can say 3 plus 4, and that's just using Python as a calculator. And we can use all these different operators, just the normal arithmetic operators. Let me take a note of the things that we're talking about. So we had variables and values. We're talking about data types, about strings and integers. And now we're taking a look at operators. So there's the arithmetic operators, and those are just the ones that you know from mathematics. You can do all the stuff that you can do there. I can divide something. I can say divided by 2, and what I get here as a result, it's a different data type again. It's also a number. You can see we can do calculations with that. Number 5 divided by 2, and this number now refers to 2.5, and 2.5 is a float. It's a different data type, but also a number, and you can do calculations with that just as we did before. Number plus 3, 5.5. If you're not sure about what data type you're currently working with, so one thing, using PyCharm makes some of that stuff pretty easy, because you have here on the right side, if you're working in the interpreter, you can see it tells you what are currently the variables that are available in this session. That's ones that we assigned before, and it's telling us, okay, there's 4, and that refers to this value, and it even tells us what data type it is. In that case, it's an integer. Here we have num that we just created, and it's a float, and it refers to the value 2.5, etc. String variables. If you're somewhere, like if you're not working with an IDE and you're just in your command line, you want to figure out what type it is, you can just ask Python, and you just ask it with type, give in your variable name, and it's going to tell you that's of the class float. So the same thing that we're seeing here. You can do this for all of the things. We type, okay, type of I, it's an integer. What's the type of var that we assigned before? That's a string. Check like what is var? Okay, that was this string that we typed in. Using the interpreter, the Python interpreter, it's a good way to get started and to just figure out what's even going on, what am I doing, what type are these variables, which ones do I have, what can I do with them, etc. So sticking with operators, let's have another quick look at what we can do with comparison operators. So thinking back to math, like it's a similar. Let's first introduce actually another data type that we have, which is Booleans. Okay, so Booleans are just true or false. That's a Boolean, and that's a Boolean, and that's all there are. There's just true and false. They're capitalized in Python. That's like one of the few things that are capitalized. Generally, most of the stuff is written in lowercase. But so we have true and false, and they are the essential building blocks of everything on the computer. You have 1 or 0. 1 is true, and 0 is false. And we can do comparisons with those that are adhere to logical principles. So to say, if you've taken some logic in school, that could be interesting. Sorry. So I can say true. Well, the comparison operators are, you have and, you have or, and you have not. So that's all there is. And we can say true and false. And this is going to evaluate false, because the and, if you use the and operator, the result of this expression is only going to be true if both of them are true. So it's similar to doing calculations that we did before. No, we're doing something, we're doing 3 plus 4, we get a result. Here we're doing true, and we get a result. So you can think of that's also why they're called operators. So you can think of the and similar to a plus, just that it has a different meaning. And in that case, the meaning is it evaluates 2, like on the left and on the right side, it evaluates 2 expressions to a Boolean, and then compares, are both of them true? Then it returns true. Is one of them false? Then it returns false. And the same thing, not quite the same thing, but or does a similar thing, only that it evaluates the true when one of them is true. So either the left or the right side. Okay, so but hardly ever you would type you would type true in there. So what we can do instead is we make an expression here. So I say, okay, is 3 the same as 3? You know, those are our logical operators. So equals is the same as. So I'm asking Python, is 3 the same as 3? And it's going to return me a Boolean as a result. True. I'm thinking about, or I can say is 4. You don't actually need to put this in brackets. I just do this for making it easier to read for me. But I can say, is 4 bigger than 3? And this is going to return me false. 4 bigger than 3, yes, that's correct. And now I can combine these expressions by saying something like, okay, is 3 equals to 3? And is it also true that 4 is bigger than 3? We know that this is going to evaluate to true. We know that this is going to evaluate to true. We know that we have here sitting a true, and we have here sitting a true. We're joining it together with an AND. So true and true is going to evaluate to true. That's what we get. And that's like, those are like the little building blocks that make up a lot of programming. You ask the computer, is this expression true? And those are just very simple expressions here, but you can think of them as becoming more complex. But always say it would boil down to is it true or is it false? And then on the other side, you have something else, and you're asking Python, is this true or is this false? And essentially, then you have this combined statement that just gives you a result depending on that. And there's this different operators. So here, comparison operators, like the ones here, equals, bigger than. There's a couple of other ones. I'm not going to talk about all of them, but you can look them up. There's like 5 is bigger or equals than 5, for example. That's just going to check, is this on the left side bigger or the same as 5? So this is going to be a true, etc. There's a couple of these comparison operators. Oh, sorry, I actually made a mistake here. Those are the logical operators. Sorry about that. Logical operators, and then comparison operators. Get them here. We were just talking about them. Equals. Is it the same as? Or we have bigger equals. We have bigger than, smaller than, smaller equals, and we have not equals. Those are the most common ones already. Not equals is like essentially the opposite of equals. I can say if I say 3 does not equal 3, I'm going to get a false because 3 equals 3. All right, so that's all about operators for now. I'm gonna go forward to so that's a little excursion into that you understand what are some basic building blocks. There's data types, text, integers like numbers, floats, and then there's true, false, booleans. And then with these building blocks of the language, we can make calculations, and that's what we need the operators for. So we can do arithmetic operations with numbers. We can say this plus that equals something, divided, etc., etc. We can say we have comparison operators where we can see, is this the same as that? And we get a boolean returned. And then we have logical operators where we can combine boolean statements left and right and say, is this and that both true, or is one of these true, or are they both not true, etc., etc. And that's the basic calculation building blocks that you work with in a programming language. So let's get back into our recipe. All right. What I want to do here is we're going to fetch this recipe. Let's run it again to take a look at it, because I'm not printing it out. Let's do that. Print. Actually, I'm going to assign it to a variable. So now we already know what it means. I'm going to say recipe equals response.text. Response is what we get back from this, and .text is something that I'm using on this response that we're getting here to actually get the text that's written in there. And now I can print that out, and I can say print recipe. I run this script now, and I get this output again. This is our text. Let's see what data type we have here. Let's say type of recipe. Print it out, and it's telling us, okay, it's a string. So what we're getting here is a large string, which doesn't necessarily make it very easy to work with. Like, what are we going to do with this? I personally think that this should just be a very basic meal. So I'm gonna try to exclude the garlic cloves and the olive oil and just make it from carrots, potatoes, peas, and tomatoes. And for that, it's a bit difficult to do this with a string because a string is just one thing. But we can think of this response like if you would make a shopping list, you would have we would have this as different lines as different items. So we're going to try to model that in Python by just saying, okay, instead of having this one blob of text, I'm going to want to split this up and store the individual items as separate items. And doing that, we can use a data type that's also very, very common in Python, and that's a list. So we're going to look at a bit at list. I want to split this recipe up. So I'm going to say, I'm first going to make a list ingredients. Okay, that's what we're going to get. And this is the syntax that Python uses to create an empty list, just square brackets. You can think of it like, I don't know, a little box that's going to hold some items in there. So there's going to be things coming in there, items in that list. Okay, something like that. But we're going to fill it up with our ingredients that we're getting from the internet. So what I'm going to say is, first I'm going to split it up. I'm going to say, let's split up this one text into a couple of lines. And this is actually going to create a list already. I'm going to do that a bit later. So I'm going to say lines equals recipe dot split. And where do I want to split it? I want to split it at the end of a line. And so that's something interesting that people who never did programming haven't heard about this character often. But the Newline is actually just a character, just like the L is a character or the O is a character. It's just a special character. And I'm gonna tell Python now to split up this one big string by the Newline character. So this \n, the Newline character. And when I do that, see what I get as a result. So I get this as a result. I get a list. You see that it created a list. We already know this from the square brackets, and it contains a couple of strings. They start with a quotation mark and end with a quotation mark. So we have 1, 2, 3, 4, 5, 6 strings in here that are the lines that were before. We can still see it here. This was our original text, and this is now our list that contains a couple of strings. And one thing I want to mention here is that like every time I run this script, the whole process happens. So every time I run this script, Python gets the request package from where we installed it. It makes this call to the internet and actually gets this recipe from the internet, pulls it in here locally to my computer and into this Python session, then gets text from it, prints it out. That's the first thing that happens. Then what we added now as a code, it splits up this one big string into a couple of different strings and then prints those out. So every time I press this Control R, all of this happens. Okay, so that's already seems more manageable. Okay, we can access each line separately. That's nice. But now the one thing that's maybe still annoying is we have this to olive oil, whatever that means. But we can't I couldn't say now, okay, instead of 3 carrots, I actually want to use 4 carrots, because this is it's still just all sitting inside of this string. So to see a bit how useful lists are, that can just hold anything. We're going to make an ingredients list now, where I split up all these strings that are in there in a similar way that we did it up there, and I'm gonna actually store it separately. We're gonna create a list of lists. That's what we're gonna do next. And for that, I'm gonna introduce something new. That's also a relatively basic concept in programming, and that's looping. So flow control, you could say. In that case, I'm gonna show you a for loop. And again, you're gonna maybe you can appreciate how nicely and like easily readable this works in Python, because what I want to do is like for every item that's sitting inside of this list, inside of this lines list, right? For every item, I want to do something. So what I write is for line, like there would be one line, for line in lines. That's the name of my list up here that I created, that I printed out here. So for every item in this list, for line in lines, what I want to do is I want to split it up. So I say like ingredient equals line dot split. If I don't pass anything in here, like if I don't write anything, then it just splits it at the empty space. I could do the same as doing this, but there's no need for that. So line dot split. What is this going to create? It's going to make another list. So out of this simple string, it's going to make a list that contains 2 strings, the 2 as a string and olive oil as a string. It's just going to do the same thing that this other thing did up there. Okay, so this is going to be a new list, and I'm going to add this list to the empty ingredients list that I have up there. And the command for that is I say ingredients.append, and then I'm going to put this ingredient in there. So this for loop is going to go over each line that's sitting here, like over each line that's in this list, split it up into 2, thereby create a new list, and it's storing this in the ingredient variable, and then it's appending this ingredient variable to the ingredients list. And look at this here. What we're doing here with this space here, that's something that makes Python also different from a lot of other programming languages, in the sense that this whitespace actually has meaning. And because it says like that anything that's indented here, when I start something off with a colon, then anything that's indented for spaces is going to be part of this command up here, of this statement. It's going to say do everything that's indented here as many times as there's items in this line thing. When I go back outside, like when I go away from this indentation and I say something, print hello, and that's only going to happen afterwards, after it went over all these things as many times as there are lines. I'll show you what our output of that is. So I'm populating this empty ingredients list with this command of splitting up the strings that are in there, and then adding it, populating this one. So, all right, let's take a look. Okay, so now we created our list of lists. We have something that looks similar as the thing that we had before. This hello, just to show you that first all these things happen, and then it prints hello. We need to have that around. So out of this one string here, it created this list that contains 2 strings because it split it up at the space between the number and the string. Okay, cool. One thing we can do is like, so I said before that I don't want to deal with olive oil and garlic cloves. So I'm just going to get rid of those. And by doing that, show you a few list methods that we can use, like things that we can do with lists. Essentially, we're going to talk about what functions and methods are in a bit. So I can say ingredients dot pop, and then I can get rid of olive oil, this whole list, and I'm going to also get rid of garlic cloves. One thing to note about that's pretty common in programming is that you start counting not at 1. So this is not, the first item is not at index 1, but it's at index 0. So it just shifted by 1. So you say 0, 1, 2, 3, 4, 5. This is how you count. So I'm going to get rid of this one, and I'm going to get rid of, well, actually, if I do that, I'm going to get 2 times rid of the first one if I pop them out. Take a look at that. So what I did here is I remove what was the first one, olive oil, and then I removed the one that was the next one at the first item. You look, so that this is not too confusing. Print ingredients, and then the one at the, like after removing the one that's currently at the first, I'm gonna remove the one that's afterwards at the 0 one, which is the next one, garlic cloves. Okay, print that out, see what's happening. Okay, so first we have this full list here that contains all of those items. Then I'm taking out olive oil, so the next printout doesn't have olive oil anymore. And then I'm taking out the new first item, and then I have a list that only contains these 4 items. I could make this with an index. I could say 1, then it would first remove the garlic cloves, and then 0 would be still the first item, olive oil, same result. Okay, let's get rid of a couple of those print statements. Just keep in mind that every time I press this command R, all of these things happen every time. All right. Okay, so this is what we're working with now. We have a list of lists that contains our ingredients, and now I want to say, okay, I'm actually cooking this meal for twice the amount of people. So let's do some calculations and increase the amount that we have in there. Let's try that out. So if I go, with that, I'm going to show you how you can, like with knowing indexes, in the same way that we popped it out here by index, we can access items in the list also by index. So I can say ingredient 1 equals from the ingredients list, the 0th item. So the first item here, 3 carrots. Okay, I run that. It's gonna just give me this one item. And the same way I can say ingredients 1, help here, ingredients 2, I see that, ingredients 3, I see that. And as you see, like what we have here is another list with items in there. So in the same way that I can access something here by index, I can do the same thing here, and I can say, okay, I just want to access the amount now. So I say, again, here from that piece that we took out of the list, I like to think of it like boxes, like lists like boxes. Like you have this big box that contains, in that case, because it's a list of lists, we have a big box that contains smaller boxes, and I pick out the small box, and from the small box, I pick out one item. That's what I'm doing with this square bracket, just grabbing into the box, essentially. So what I'm gonna get here is 3. Okay, and when I do the same thing for another ingredient, for the second one, 3, 3, ingredient 2, I assigned the same one. I want to pick a different one. So I'm gonna pick first, I'm gonna pick carrots, and then the second time I'm gonna pick the potatoes. Control R. Okay, interesting. So that wasn't on purpose, but it's nice to show you what was happening here. So I wanted to pick 2 times the amounts, but the second time, I changed both of those indexes. The first index is just picking from the big list. So here it's correct here. From the big list, I'm picking the first one, and in this line, from the big list, I'm picking the second one. But then what I did here is I changed that also. And that means that from this second one that we're referring to here with ink2, I'm actually picking the second item, which is the name, not the number. So this should stay with 0 so that I can access this number 2 here. And by the way, if you're interested in programming, just play around with stuff. So if you make any mistakes on the way, that's totally fine. Just keep going. Everyone makes mistakes, and that's really not a problem. And it's actually really great for learning. So what I'm trying to do here actually is I want to show you I'm leading us up towards an error. So it would be nice now to say, okay, so we have these 2 items, and I just want to add them together, right? So I want to say I want to add carrots plus potatoes, the amounts. Maybe that doesn't make the most sense in a recipe, but let's do it anyways, all right? So I'm saving this amount here, amount 1, and doing the same stuff down here. Amount 2, and then we saw that before we can just add stuff together. So what if I say amount 1 plus amount 2? Print out the result of that. Okay, and so that's what I'm getting here. I'm getting 32, but thinking about 3 plus 2 doesn't really equal 32. So why am I getting 32 in that case? The reason is that, as you can see here, with the items, with our amounts, at the moment they're strings, and they're not numbers as we would want them to be. So Python has this thing built in that if you use plus on a string instead of an integer, then it just sticks it together. So what it's doing here is literally it's adding this string to the end of that string. That's why we're getting 32. But that would be very confusing if we're actually building some application that does some calculations for our recipes, because that would be, I guess you'd have to invite the whole extended family to get rid of that food. So in this case, what we need to do first is we need to do a type conversion. And that's something that also happens very easily in Python. Let's hop back to the console just to try that out a bit. So we can say, sorry, I see something here. We can say, we can take this, so wait, what I was trying to do, getting a string. So we're making this string 1, that was number 2, and then another string, number 3. Just to show you that again, if I add those 2 things together, I get 23 because I flipped the, yeah, anyways, so these 2 are added together. What I want instead, though, is I want them as numbers. So what I can do called type conversion is in Python very simple. I can just say, okay, I want this. I want string 1. I want number 1. I want this to be an integer instead of a string. So I'm saying this string 1 variable, what this refers to, which in this case is 2. I want to convert it to an integer. Simply doing this with this int statement. So now num1 is going to be 2, and we can see here that that's an integer. We can also ask Python, we can say what's the type of num1, and that's an integer, and the type of string 1 was a string, even though that when I print them out, they look similar. But as you can see by the quotes around there, one is a string, and the other one is it's actually an integer. So in order to make these calculations up here, I'm gonna have to convert them to integers. Before we go ahead to we're gonna do this. Yes, we're gonna do this. But what I want to introduce now, and type conversion would be 1 equals making an integer from amount 1 and printing it out. Let's print out the type so that we know that this worked out well. Okay, class integer. Just take a quick look at the time. Oh, okay. All right. We've got only very little time left, and we didn't get all the way where I wanted to get. Sorry about that. Let's see. We talked about packages. We talked about the setup. We talked about packages, how there's a lot of power in that. We talked a lot about the Python basics, about variables, variable assignments, data types, strings, integers, floats. We talked about operators, logical operators, arithmetic operators, and comparison operators. We talked about loops a bit, and by introducing the for loop. And let's get to talking about functions, because that's a really important concept in programming too. And I think we're gonna have enough time to do that. And then I promise that the project that we're going to send out, it actually has a lot about object-oriented Python, because we're going to essentially be working with, like, you might have seen that it's a bit like clunky to work with our ingredients list like that we have to access it by index, and then we have to access by index what's the number in there by another index. So that gets really confusing. And using object-oriented programming makes a lot of that stuff much easier. So we're going to build, I'm going to show you in this other project then how to build a class, an ingredients class that we can then much easier work with. But because we only have so little time left, I want to talk to you here about functions. Because another thing that, so let's say that we have all these items in our ingredients list, and now I want to make a mash of carrots and potatoes. So I just want to stick those two together, for example. And then I want to mash potatoes and peas, and then I want to mash carrots and tomatoes, whatever. So that would be a lot of work to go in there and type out the code for everything every time, if I want to do it a couple of times. So one essential concept in programming are functions that just abstract this behavior, make like a blueprint that then allows you to just do the action over and over again really quickly. And in Python, we do this by defining a function with the def keyword. I'm just going to call this function mash, and I'm going to give it two ingredients, ingredient 1 and ingredient 2. And with these ingredients, what I'm going to do is just make a simple one for now. I'm going to print out. The names of these two ingredients in the, like what we looked at before. We can add these two things together. So these are two strings, ingredient 2. However, it depends on what I'm passing in there. if I'm passing an ingredient from our list, I'm going to have to say, okay, I just want to mesh together the string. And we said like the name of the ingredient is at the first, like the second position. So these two strings, I'm going to mesh them together. I'm going to say, here's some yummy, and then just the name of this combination of things, whatever we pass in there. Let's try that out. Okay, so that's defining a function, and in this case, the function, all the function does is it prints out something. But I just want to show you like this conceptually, like what's the important part about that. So if I can now I can call the function. This in itself doesn't do anything. That's like defining a variable, similar to defining a variable. I'm saying a Python. If I talk about mesh, then you know what I'm talking about. I'm talking about this. So now to actually do something with it, I'm gonna have to talk about it. So I say mesh, and you can see that PyCharm already gives us, okay, what do I need for this? What I defined before. I'm gonna need to pass it 2 ingredients. In our case, we're picking them from our ingredients list, taking from the web. I'm gonna say from the ingredients list, take the first one and take the second one, mesh them together. And so that we can see something, we also have to, in that case, not, because we have a print statement. So if I call this function, it's gonna give me the output of here's some yummy carrot potatoes meshed together. Okay, and now what I can do is I can call this function as many times as I want, and I can call it with different inputs. I can mesh these two things together, or I can say, what about this and that together? I'll just call that. And you can see that without needing to write all this, here is some blah, 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 again, I just keep getting the same output, but with a different input. So here I'm creating some carrots, potatoes, and some carrots, peas, and some potatoes, peas. And this, and that's a very quick explanation of what functions are. I'm sorry that there's not enough time to go into this a bit more in detail, but again, like it's going to be in the project. Just keep in mind that there's like lots of functionalities. One thing that you can do anytime when you're writing a script or when you're doing something with programming, if you notice you're doing something like more than 2 or 3 times, you should probably write a function, because it's likely that you're going to use it more often. And by not writing the function, just typing it out again or copy pasting, there's a lot of errors that can happen. So functions are great. And I'm gonna wrap up with this now. 1 minute. No, we're gonna do this because it's so easy. I'm gonna show you how to do a file input output. If you want to hop off, there's only 1 minute left. I'm gonna move object-oriented Python into the project that Tim's gonna send out later. But let's take a quick look at file input output, because it's a very powerful thing and it's actually very easy to do in Python. So we changed our ingredients list to file input output. And we want to write it back to as a new, like as a thing to as a new recipe. Okay, we change our recipe and we want to write it out again. So what I can do with that in Python is I just type with open, give it a file name. I'm going to call that new recipe.txt, just a text file, and I put it into write mode. Okay, so that's the W just means, okay, I'm going to write to this file now. And what I want to write in there is essentially just actually with open as file. I need to give this also, that's a shortcut for assigning, essentially assigning a variable to what we're creating here. And here I'm going to file.write. And I'm going to write very quickly, I'm just going to write our ingredients list back out there. So when I run this, I'm going to have to convert this to the string. You see the PyCharm is telling me that there's like Python can only write out strings, so I can do this, and it would create this. It would create this new recipe file here that contains now list that we just created as a string. This is maybe not the best way to look at this. So instead, I'm just going to actually write out this response to text, the thing that we fetched from the internet, just as it is now. We still have that sitting around. That's our recipe. And if I write out our recipe to file, and then look at this file, then we have the resource that we had sitting on the internet suddenly in here on our local computer. And now we're going to send out the code. Like that's part of this. And in the other code, where I'm also working over changing the recipe a bit and like adding, just after we convert these numbers, after we convert these strings to numbers, we can do arithmetic operations with them. We can say multiply by 2 everything, and then we give it a new recipe that has like different numbers on the side. Okay.
Hey Martin.
Yeah.
I was just going to say, if you want to just continue going, definitely if people need to hop off, they can. But if you wanted to just continue going with the object-oriented stuff, you definitely can. That way we can, when we send out this recording to everybody, it'll be on there. Or if you prefer to do it in a separate one, it's totally your call. But it's up to you.
Okay. Thanks. Sure. Okay. Let's talk over it. Maybe someone still has some time to hang around. I'm on the roll. Let's just keep it going.
Yeah, you're doing great, man. This is really, really cool.
Thanks. Okay, then, well, all right. If we have some extra time, then let's just wrap this up like that. Where we did file input output. You can see that after this type conversion, you can edit the numbers. You can do calculations with it. You can write whatever you want back to this file. Let's extend on that a bit, make it a bit nicer. I'm gonna say, first I'm gonna write a line that says recipe, and I'm also gonna add this Newline character that we already talked about. I'm gonna make 2 new lines, and then afterwards I'm gonna write the recipe that we just looked at. Run this again. And up here we see we added this title to our recipe, whatever that recipe is going to be. I don't know. Maybe it's going to be a good soup. Okay. So then let's hop over let's move this to the side. Yeah, and reading files in Python. So what we did here, like this is we're actually fetching something from the web. What we could also do in a very similar syntax to this one, I can say with open, give it the name of the file, new recipe txt, and then a different mode. So I'm going to say here that's just read mode. So I don't want to do anything with it. I just want to get the content in as file. I'm going to get I'm going to just assign it to new recipe file.read, and then I can print out the new recipe in here. And in a similar way as before, there's a bit too much going on here. Get rid of those print statements. In the same way that we got the recipe from the internet before, here now I have this new file that I'm just reading from like here from my computer. And you see that because it also has this title that we just added before. Okay, so let's wrap that up and move over to taking a quick look at object-oriented Python. We're going to talk about classes, methods, and instances real quick. For that, I'm going to create a new file here, and I'm going to call it ingredients. .py. And what we ran into a lot in here is that it's like this clunky to work with it. We tried to make this mesh this together, and we had to like access it from inside of a list. Like when passing it in, we had to access it inside of a list, and then here the different items we had to access from a list. And it's like difficult to keep track of what's going on. So I do calculations with it. We have to do this conversion, etc. So what I'm going to do instead here now is I will create a class that models an ingredient, like a piece of food item, essentially. So object-oriented, the essential idea of object-oriented programming is that you're trying to recreate the world around us, like in the way that we perceive things. We say, we can think of a carrot as a thing, as an object, and that's why it's called object-oriented programming. And we're just going to create an object that represents this carrot. In this case, we're just going to pick like the name, what is this thing, and how many of it do we want to have, do we want to work with. In Python, to create a class, what you do is you type the class keyword, and then you type the name of the class, and that's the first, one of the few times when you use actually capitalized names, and this is reserved for classes. That's why you shouldn't use it somewhere else, because if you use a capitalized variable name, everyone's going to think that it's a class. So I'm gonna create this class, and you see it's a similar syntax to defining a function before. Just instead of the def, I'm using the class keyword, and inside of here, I could just make an empty class like that. I can say path. Okay, so that this doesn't really do anything, but we already created a class. If you look at this from the console, I'm just gonna restart that so we get rid of all this code in there. And this file that I just created here, that doesn't contain anything but these two lines. That's already a Python package. In the same way that earlier we imported the requests library, we can here import this package that we just created. So I can say import. I'm actually going to say from ingredients. That's the name of our package. I'm going to import ingredients. So that's our class, the empty class that we just made. So now I can say there's no error, so that's all fine. So now I can say, okay, I want to look at this. I want to say, okay, ingredient 1 equals, it's an ingredient. So in the same way that calling the function before, like using these brackets, makes a call, is going to create one object, one empty object, an ingredient. We can look at that. What does it mean? Okay, in the same way that before, or that we can say this is an integer. We can see here, okay, that's just an ingredient class from the ingredients package. And this is like where you can see that everything in Python essentially is just an object. So these integers that we're working with here is just a definition similar to how we're going to define this class here. The figure again. Okay, that's better. Only that it's already part of Python by default. Like, so we don't have to create an integer class because someone did and included it in Python. But if we want to build custom objects, we can do that, and we can work with them in the same way that we work with those built-in items. The more we define about it, the more we can use about it. But yeah, I just wanted to show you here that like now we created an empty type of this ingredients object. It currently doesn't do anything because we didn't define anything. We didn't say that it should have any capacities. So what happens when I do this? Where did it? Ingredient 1, calling that's like creating an instance of an object. That's how we call that in object-oriented programming, and it means that calling this like it's something like calling a constructor. It's a bit different in other programming languages. In Python, it doesn't quite mean the same, but there's something that gets called every time that I do this, that I create an instance of a class with this syntax, and that's that there's a dunder init function being called. That's just how it's called, because it initializes an instance of an object. So if I wanna have something happen every time that I create a new instance of this object, I can write it into this def init method. And you can see that this is very similar to the function that we looked at before here. Like the same syntax, we say def, give it a name, and then pass it some things, and then we write some code indented. The only difference is that here it's happening inside of a class, and that's when we call it a method. And you can also see there's this self thing that's already in there in the arguments, and that just means that the instance that we're creating is like passing itself. that's what differentiates a method from a function. Otherwise, it's essentially the same. So this has access to whatever the instance of this object holds. So what we said that we want to do is we want to give it a name and we want to give it an amount. So these are two arguments that we want to pass to this method, to this init method, when we create a new instance. So these are going to go in here into the brackets when we make an ingredient. And I have to assign it to self.name equals name. So here we're doing a variable assignment. Same thing, it just looks a bit different because there's this funny self thing in front of it. But all I'm saying is like whatever gets passed in here into the brackets when making one, I'm going to assign it to the instance of this object that we're creating here and to the name variable. And same thing with the amount. Okay. So now every time that, so let's try this again. I'm going to have to restart the console here and import again. From ingredients, import ingredient. So now when I want to make one and I do it without passing anything in there, I'm going to get an error. It's telling me, okay, the init function, the thing that we just defined up here, it requires name and amount to be passed in there so that it can successfully create this ingredient object. And that's, as you saw before, if I don't define this in there, I'm not getting an error. Then it just allows me to create this empty object. But in this case, I said every ingredient has to have a name and it has to have an amount. So let's do that. Instead of not passing anything in there, I'm going to say carrots, and I'm going to say string. So you see I'm passing here a string, and then I'm passing an integer. And because Python is like dynamically typed, I don't have to like define in here anywhere that amount has to be an integer and name has to be a string, which can also cause some problems because I could pass an integer here, and then later on I would maybe expect that to be a string, and then that could potentially break things. But as you see here, I can just, it also makes things easier on the other hand. So what I did here is now I created this ingredient, assigned this ingredient variable to an ingredient object. In the same way that you see here, integer, string is the ingredient written down here. And we see that it contains, like similar to a list in a way, it's an object that contains an amount of 3 and the name of carrots. So, and this makes like working with our ingredients much easier. Let's make it a bit more understandable. I'm going to say ingredient, I'm going to call it carrots, not just ingredient 1. Okay, the same thing. And let's make some more. So I make some peas. I'm going to call it ingredient peas. And there's going to be 20 of those. I can see here we have now a carrot object with the amount 3 and the name carrot, with peas object with the amount 20 and the name peas. And I can access those by just saying peas.name. Or I can say peas.amount. And I have access to those instance variables. Those things are called instance variables because they're variables that are specific to the instance of the ingredient class that we created. Same way I can say carrots.amount, it's going to tell me 3 because I'm accessing that instance of that carrots ingredient instance of this object that I just created. I'm accessing the amount instance variable, and that's 3. So now you can see already that this makes some of the operations that we were like trying to do before much easier. I can say I can make a calculation. I can say carrots.amount plus plus peas.amount, and I get 23. Or I can multiply it. I can say carrots.amount times 2, and we have 6 carrots. So yeah, so just creating a very, very simple object like this one that only takes name and amount makes some of these operations just somewhat intuitive, you know, like because that's how we're used to interacting with the world. So it makes also interacting with code somewhat easier. That's why object-oriented programming is also widely used, and there's a lot of big languages that use object-oriented methods to interact with code, essentially. Now, something else we can do in here is I want to be like later on when I'm cooking with this item. Well, actually, let's take a look at this first. What happens when I print out carrots? What do I get for that? Okay, so I get ingredient, like this. What we see here on the side also. It tells us ingredients object at, and then some cryptic number. It's just a memory address. It's essentially like telling the computer where it's sitting in memory. But that's not very informative. I would much more like that if I say print carrots, that it tells me what's the name of this, because I don't necessarily need to name this carrot. We also have this other one that's just called ingredient, and here I don't know what that is. Like I have no clue what is this ingredient object. So it would be nice to if I call the print on it, that it gives me out like the amount and the name of it. And there's, not so surprisingly, a way to do that. That's another of this dunder methods. If I define dunder string, this one tells me like it has to have access to the instance, that's the self variable, and now I can just make it return a string that is informative and contains whatever I want. I could say return hey. That wouldn't be very informative. Then just if I would print this ingredient here, it would tell me hey instead. But what I want to do is I want to print out self.name and how many there are. So I can say, I can even make a little message. I can say there are of this item, there are self.amount. It's going to be whatever fits in this instance variable's amount, and then self.name, however it's called. So going back to this, I have to import again because I changed something. I can say from ingredients import ingredient, make an object. Let's name it not very well. I'm just going to say ingredient, and it will be carrots and 123 this time. Okay, and now when I print it out, it tells me the string that I just defined before in this on the string method, telling me there are self.amount 123. That's what I passed in there of carrots. Inc2 and make another potatoes 0 and another instance, and then looking at this one, we get a different output formatted in the same way. Okay, there are 0 potatoes left. All right, so that's a useful thing to define for the class that you make, so that you have a good idea of what's actually going on. If you don't have such a nice thing sitting here on the side that tells me already what is actually contained in this variable. But if you're just working from your terminal, you don't have this output here. So you define a string method, and you can, if you're building a Python package that you put online and other people are going to use it, you can rely on that they look at it like this. So you define the string method so that they can have an idea of what's going on. Okay, so that would be a custom dunder string. They're called dunder. These methods are called dunder methods in Python because they have this dunder double underscore. So custom dunder string. What we did here is we made a initialization method, and now let's take a look at other like methods that you can define inside of a class that you can then apply to similar to abstracting something with a function that we did before. In a very slimmed down example. Here we want to do something that works like an action essentially that each of those ingredients objects can perform in a way. So I'm gonna make a use method because I'm building towards doing some cooking here. So if I make I'm gonna make a use method that takes the ingredients instance, it's the self object, and it's also going to take an amount. How many am I using? And what's going to happen, what I'm going to make happen in there is I'm going to essentially just reduce the amount of that instance. So always when I use this self prefix, then it's doing something to the internal state of this object. And I'm going to reduce, that's a shortcut for doing something and reassigning it again. I'm going to remove the amount that we passed in there. All right, let's call this, oops, sorry. Use amount, make it a bit more clear. So from the self amount, I'm reducing the use amount. And by defining this method, I have like each of my instances is going to have access to that, and so I'll be able to change the amount that of carrots that I have. Let's give it a try. Gradient. Make some peas, and I have a lot of peas. Okay, or we can also use the print method that we just defined before. Okay, there are 200 of peas. So, and now what I can do is I can use the use method on this p in the same way that I'm saying inc.amount. I can say inc.use, and it's PyCharm is again telling us what do we need. We need to pass it itself, and that just means anything that's before the point. That's how the self translates. I can say inc.use and give it an amount, and I want to use 20 p's, and you can see here already the amount was reduced by 20. And then I print out my ingredient object again. There's only 180 p's left. And this is going to work for any instance of the object that I create, essentially. So I can make a new one, or even, yeah, let's make a new one. Inc2 this ingredient carrots again, and 3. Inc2 dot use, and just take a look here. What's happening? We have 3 carrots. We defined it, and I'm gonna eat 2 of them. I only have 1 carrot left. Now, what's okay? I'm gonna leave it at that, and so I'm gonna leave it actually with a cliffhanger. There you go. If I say, what happens if I say use, and I know I have 1 carrot left. What if I want to use 7 carrots? What's gonna happen? I'm actually going into the minuses. So that's not very useful, right? Because I can't use 7 carrots when I only have 1 carrot left. So there's a way that we have to improve this method to make it like give us an error and say, oh, no, sorry, you can't do that if we're trying to take off, like use more carrots than we have. I'm going to build that out though in the project that we're sending out later and wrap it up for now. Thanks for paying attention for so long. Let's see. Let's do a quick recap. Yeah. So what I talked about now in this 1.5 hour webinar is what is programming. I'm just going to do a quick recap on that. We opened up a text file. We just wrote some text in there and then ran it from the command line. And that's really all it is. So text in a file with a certain extension, and then you have an interpreter that runs it. What makes Python powerful is the large ecosystem and a very welcoming community. There's like people working on projects all the time and making packages that you can just use to abstract a lot of like code logic that is difficult to do in pretty simple and very readable kind of way. So it's Python is like a really good language to get started, but to keep building with it, because it's used like in, I don't know, like Instagram is built on Django, which is a Python framework, and machine learning is largely to a large degree run in Python, etc., etc. Next, we went into fetching a web resource using one of those packages with essentially just this one line of code here. Do we have it up there? Response requests.get. We fetched the web resource and then worked with it a bit. We looked at reading and writing to a file, which also is just a very simple state, just a few lines of code. With open, you give it a name, write to it, write in what you want to write. It has to be a string. And reading to a file is similarly easy. Then we talked about Python basics. We did that a bit before. We talked about data types, strings, integers, floats, lists. There's a couple of other ones. And as you saw in this, if you stuck around for the object-oriented part, essentially everything is just an object. So all this data types are just objects. So you can create your own ones. There's dictionaries that we didn't talk about. They are a pretty big and very useful data type. And there's going to be some in the some about dictionaries also in the project later on. We talked about operators. We talked about doing arithmetic, doing logical operations, and doing comparison operations. We talked not about conditionals. That's okay. Sorry about that. We're gonna, yeah, it's gonna be in the project later on. There's lots of conditionals. I'm gonna show you a very quick example of that, just so I don't leave you hanging with that. And if it's essentially if like there's if statements, I can say if 3, I can say if, so if 3 equals 3 is true, then do something. Okay. That's a conditional. It's a statement where you're asking Python a question. You're saying like, is this like that, or is this not like that? If you're doing, if not, do something. If it's not like that, don't do it. Or there's yeah, okay, I'm not going to go too deep into that. Sorry. So then we talked a bit about loops. There's a for loop that we looked at. There's also another type of loop that's called the while loop, which runs very similar. Like if you understand the concept of the for loop, then the while loop is going to be easy to understand. And finally, we talked a little bit about object-oriented Python. We modeled a class, an ingredients class that kind of like makes it easier for us to handle the items in this recipe. So we talked about classes in general, like this is these blueprints that we create. We talked about instances, that's the actual things that we make, like when we pass something to the, when we're constructing the class instance, the object. And we talked about methods that would be, for example, the use method that then is part of each of those class instances, and that you can use on all of them. Yes, and then I've talked a little bit about this project that I built on the side, and I'm gonna record some videos for that, so that you have a even more comprehensive, like this project goes into more depth in a couple of these things. I'm gonna talk about conditionals in there too, and we're building out a couple of more concepts of object-oriented Python, talk about class methods and things like lots of additional stuff. I hope it's going to be interesting. Essentially, we're going to just make some soup or bake some pizza using Python classes. And I hope you're going to enjoy it. And I hope that you took something useful from this tutorial, from this webinar. And that's it for now. Saying bye. Thanks for listening. Oh, wait, there's some chat. Thank you. All right. Thanks, everyone. If you're interested in any of our courses, visit the website, hop on codingnomads.co. There's also like a new platform coming out starting like sometime early 2019. If you're interested in that, just write to Ryan or me or Kim, and we can get you started as beta testers. If you have any other questions about the courses or any other questions about Python that you want to talk about, you can write me an email, contact me over, or contact Kim and Ryan, and we're happy to answer any questions that come up. And that's it. Thanks for listening, and maybe hope to see you at some point, or hope you took something useful from this. Bye-bye.